All right, so today we're diving into a Java framework that asks a pretty radical question. What if we've been thinking about the whole client-server relationship all wrong? It's called wffweb, that's the web firm framework, and let me tell you, it has a totally fascinating approach to building web apps. Now, if you're a Java developer, this question probably hits pretty close to home, right? You want to build these rich, super responsive user interfaces, but that usually means you're wrestling with massive JavaScript frameworks, complicated state management, and of course, the constant security headache of exposing your logic to the client. It's just a perpetual balancing act. But what if you could just sidestep that whole balancing act entirely? What if you could build, manipulate, and control your entire UI right from the server using the language you already know and love? Well, that is the core promise that we are going to unpack today. To really get what makes this framework so different, we first have to set the stage. We need to frame the exact problem it's trying to solve. So let's take a look at the puzzle of modern web development. You know these hurdles. I mean, these are the things that drive developers nuts day in and day out. You've got state synchronization, which, let's be honest, can be a total nightmare. You have business logic for the UI that you'd really rather not have exposed in client-side code. Then there's the whole universe of JavaScript build tools, which can feel like a full-time job just to keep up with. And of course, the classic HTTP request-response cycle, which piles on performance overhead with every single click. Okay, so how does wffweb even begin to tackle all this? Well, it's not just about a small improvement here or there. It's a completely different way of thinking. Instead of trying to patch up the old model, it introduces a brand new paradigm for building user interfaces. The central idea here is something they call object-oriented HTML. And the concept is actually really simple, but it's incredibly powerful. Instead of writing HTML files or messing with templates, you just instantiate Java objects, like new form or new input. Every single tag, every attribute, becomes a Java object that you control 100% on the server. So here's what that actually looks like. On the left, you've got the Java code, written in a nice, modern functional style. You're just creating a form object and giving it an input and a button. And on the right, that's the result. Perfectly clean, standard HTML. There's no weird templating language, no magic strings, just a direct one-to-one mapping from your Java objects to the final HTML. Now, that all sounds great for making a developer's life easier, but let's ask the big question. How does it perform? I mean, an architecture like this could be painfully slow if it's not done right. But wffweb was built for speed right from the start. So let's look under the hood at the engine that makes it so incredibly fast. Okay, the first secret to its speed is a big one. It completely eliminates disk I/O. Think about a typical web app. The server has to read template files from a disk, and that is a major performance bottleneck. wffweb just skips that whole step. The entire page is generated dynamically in memory from your Java objects, which is just orders of magnitude faster. The second performance pillar is communication. Instead of the old clunky overhead of HTTP, opening a connection, sending a request, getting a response, closing the connection, and doing it all over again, wffweb uses a persistent WebSocket. Once that single connection is open, the client and server can have this low-latency, two-way conversation without any of that repetitive setup cost. So when you put it all together, you get this performance trifecta. Pages are built in memory, which is super fast. UI updates are surgical. They only change what's needed, which saves CPU and memory. And all the communication happens over a hyper-efficient WebSocket. This three-pronged attack is what makes the whole thing so quick. Look, a clever idea and raw speed are awesome, but can you actually use this thing in the real world? For production apps, you need more. So let's explore the features that make wffweb a serious contender for your next enterprise project. First up, the big one for any growing application, scalability. You might think that a stateful server-side UI framework would be a nightmare to scale out horizontally, but it turns out the way it's architected actually makes it surprisingly simple. And this right here, this is a huge deal for anyone who's ever had to manage a server cluster. Because of its architecture, you don't need to configure sticky sessions, where a user always has to be routed back to the same server. You can just deploy your app across a bunch of nodes, stick a standard load balancer in front of it, and it just works. That simplifies your infrastructure a lot. Okay, next, let's talk security. This is an area where a server-centric model like this really shines. By keeping your UI generation and all your event handling logic safe and sound on the server, you massively shrink your application's attack surface.
There's no sensitive business logic just sitting out there in a JavaScript file for someone to pick apart and reverse engineer. This makes it a really compelling choice for apps where security is everything, like in fintech or healthcare.
Let's make this super concrete. How do you actually talk to a browser API from the server? Well, here's the flow for getting a user's location. The onClick event itself is defined in your Java code. That event tells the browser to run a tiny JavaScript snippet to get the coordinates. Then, and this is the cool part, that data is sent straight back over the WebSocket directly to a Java method on your server, which receives the latitude and longitude as native Java doubles. It's full server-side control. And if you want to squeeze out every last drop of performance, wffweb is fully compatible with GraalVM. This lets you compile your entire Java application ahead of time into a native executable, giving you near-instant startup times and way lower memory usage. And this isn't just some theoretical thing. The sample projects show you exactly how it's done. You run a Maven command, which generates the native image config, then you run another to build it. And the result is a single, self-contained executable file that you can just run. It's that straightforward. And you're not locked into some proprietary styling system either. Because at the end of the day, wffweb is just generating standard HTML. You can easily integrate it with all the popular CSS frameworks you already know and use, like Bootstrap, Foundation, and Material Design.
So, after looking at the philosophy, the performance, and all these production-ready features, we have to ask the big question. What does all this mean for your next project?
And if you're wondering if you'd be alone in using this, well, this is not just some niche project. The number you're seeing, 550, is the number of new projects reportedly adopting it every single month. There is a rapidly growing global community that is finding some serious value in this server-first approach. So let's boil it all down. What are the key takeaways for you? First, you get full granular control over your UI right from your Java code. You get the simplicity of keeping your logic in one language in one place. You get a massive performance boost from its smart architecture, and you get a more secure application right out of the box. And this really is the fundamental question that wffweb asks all of us to consider. For Java developers who are looking for more control, more simplicity, and better security, the answer might just be a resounding yes. It challenges us to rethink that old client-server divide, and maybe, just maybe, it's time to bring the UI back home to the server.